Hey, welcome back. I know you've been doing a lot of research on post and beam framing, maybe even for a project you're thinking about. So I thought it would be great to, really dig into that article you sent, The Superiority of Structural Post and Beam Framing for Light Building Design and Construction.
Yeah, great choice. That article really gets into why post and beam is becoming so popular,
Yeah.
especially for people interested in building sustainably.
Right. Because, thinking about my current house, it's all load-bearing walls.
Yeah.
Just the thought of trying to renovate anything, ugh, it gives me a headache. So this whole idea of, I guess, concentrating the weight on beams and posts, is that what makes post and beam so much better?
Yeah, exactly. I like to think of it like this. Traditional framing where the walls are load-bearing. Yeah. It's like, ooh, like the walls are crutches. They're doing all the work. And it really limits what you can do design-wise. Like if you want to change things later, it's nightmare. But post and beam, it's more like having a really strong skeleton. So everything else is free to be more uh, flexible.
Okay, that actually makes a lot of sense. But I do have to admit, I'm a little skeptical about the cost. Because, I've heard that engineered timber, that can get really expensive. So doesn't that make post and beam just automatically more expensive too?
Well, not necessarily. It's true that the materials themselves can sometimes cost more up front, but you often end up using less material overall. And you have to think about the long-term savings too. Like post and beam is super durable, so you won't have to do as many repairs. And if you do want to make changes later, it's way easier and cheaper.
Hmm, interesting. So it's kind of a trade-off then. Higher initial cost, but you save money in the long run. And speaking of long-term benefits, that article really emphasized how strong and durable post and beam is. So what is it about this system that makes it so much stronger than traditional framing?
Well, it all boils down to how the weight is distributed. Instead of spreading the load across all the walls, like in traditional framing, post and beam concentrates that weight at specific points, the posts and the beams. And that lets you use much stronger materials like aluminum, steel, or engineered timber. And you can use them very strategically. So you end up with a structure that can handle a lot more weight. And it'll last a lot longer, too.
Right, so it's not just about the materials themselves, it's how they're used. Kind of like those old barns you see,
Yeah.
built with those giant timbers. They seem to last forever. But are those super strong materials always the best choice when you're trying to build sustainably?
That's a really great question. And it highlights something really important. You always have to consider the whole life cycle of a building. So, yeah, those traditional timbers, they are incredibly durable.
Yeah.
But getting them sustainably, that can be a real challenge. That's why a lot of modern post and beam construction uses things like engineered timber,
Okay.
which is often sourced from forests that are managed sustainably. And sometimes they even use recycled materials.
Oh, that's cool. So it's not just about strength then, it's about getting those materials responsibly too. And what about those other materials you mentioned? Like aluminum, I know that's really easy to recycle, but is it as strong as steel or timber?
Oh, aluminum is surprisingly strong, especially for how light it is. It's actually one of the most recycled materials in the world. I mean, think about it. Pretty much every aluminum ever made is still out there somewhere.
Wow, yeah. So we could be building houses with materials that have already been used and recycled, for generations.
Exactly. It's pretty amazing. And it really shows how sustainable building can be circular. With post and beam, you can choose materials that are not only durable, but they also have less of an environmental impact from the very beginning. And then at the end of their life, you can recycle them.
Right, it's all connected. Okay, I'm starting to see why post and beam is such a good option. But that article also mentioned something called thermal bridging. I vaguely remember that from my research. Could you maybe explain that a bit more?
Sure. So thermal bridging, it's basically like a weak spot in your insulation. It's when heat escapes through the framing itself, because the framing is a better conductor of heat than the insulation is. It's like having tiny leaks in the thermal envelope of your house. But post and beam, especially systems like M.H.S. that use thermally broken aluminum, they minimize those weak spots.
So it's not just about the insulation itself, it's how the framing and the insulation work together to create a really well-sealed, energy-efficient building. That makes a lot of sense. And I guess that has a big impact on energy efficiency then, right?
Oh, absolutely. When you reduce thermal bridging, you're wasting less energy on heating and cooling, so your utility bills go down.
Yeah.
And your carbon footprint shrinks too.
Okay, so lower bills, smaller carbon footprint, those are definitely perks I can get behind. But let's shift gears for a minute. We've been talking a lot about the practical benefits, but that article also talked about how post and beam can create these amazing open spaces. Is that really a big difference compared to traditional framing?
It's Definitely one of the biggest things that draws people to post and beam.
Mm.
Because you don't have load-bearing walls everywhere. You can have these really high ceilings
Mm.
and rooms that flow into each other. And you have so much more freedom to change things up as your needs change.
Yeah, that sounds pretty amazing, especially compared to my house, where every wall seems to be important. But wouldn't those big open spaces be harder to heat and cool?
It's a valid concern. But remember, we're talking about a system that's inherently better at insulation. And if you make smart design choices, like taking advantage of passive solar gain and natural ventilation, you can actually make those open spaces very comfortable and energy efficient.
So you're working with the design, not fighting against it. That makes sense. Now, I know you're a big fan of the MHS aluminum framing system, and I can see why. But how does it compare to all this new technology we've been talking about? Does it still hold up?
That's a great question. I think it's important to remember that different framing systems are good for different things. MHS is a really solid system with a proven track record, especially when it comes to energy efficiency and durability. And it's perfect for light building applications. Plus, the fact that it's so recyclable, that's a huge bonus.
Right. We talked about how that aluminum can be recycled almost forever. It's like building for future generations. But what if someone is really interested in using those bio-based materials? Would post and beam still be a good option for them?
Absolutely. One of the best things about post and beam is how versatile it is. You're not limited to just one material. In fact, there are already companies using engineered timber made from bamboo or fast-growing trees like poplar. And as research into biocomposites keeps advancing, I think we'll see even more ways to use them in post and beam construction.
So it's not like you have to choose one or the other. You can use post and beam as the framework, and then pick the materials that fit your sustainability goals and the specific needs of your project. That's pretty cool. But let's get back to some real-world examples for a minute. I know you've worked on some amazing projects that use sustainable framing. Are there any that really highlight the benefits we've been talking about?
Oh, there are so many. But one that comes to mind is this residential development I worked on recently. They used M.H.S. framing to build a bunch of net zero energy homes.
Net zero energy homes, that's like the ultimate goal, right?
Pretty much. These homes were designed to produce as much energy as they use over a year, mainly through solar panels and some really efficient systems. But the framing played a big part too. The thermally broken aluminum really minimized energy loss. And they had these open floor plans, so they could place the windows strategically to maximize passive solar gain.
So the framing wasn't just about holding the building up. It was a key part of making the whole house energy efficient. That's awesome. But what about people who aren't building a brand new house? Can you use post and beam for renovations or additions?
You definitely can. Of course, every project is different, and there are always challenges depending on the site. But post and beam is often a good choice for integrating with existing structures. Like, I worked on a project where we added a second story to a house, and we used a kind of hybrid framing approach. We used post and beam for the addition, which gave us a more open floor plan upstairs, and then we tied it into the original structure seamlessly.
Oh, that's really cool. So you're getting the best of both worlds. Combining the strengths of different framing methods, that's encouraging. I'm starting to see how you can use post and beam for all sorts of projects. New construction, renovations, everything. But I'm guessing there's a bit of a learning curve. Are there enough skilled builders out there who know how to work at this stuff?
That's a good point. Post and beam definitely requires a specific skill set. But there are more and more builders and contractors out there who are getting on board with these advanced framing methods. And there are also some great resources available now, like training programs and online communities that are helping to close that knowledge gap.
So it's about finding the right people with the right expertise, and it sounds like that expertise is becoming easier to find. But let's shift gears again for a second, because there's another aspect of sustainable building that's been on my mind lately. It's not just about reducing our impact on the environment, it's also about building for resilience. Especially with climate change and all the extreme weather we've been seeing, it's kind of scary to think about. But we can't ignore what's happening with the climate. All the wildfires and hurricanes we've been seeing, it's a wake-up call, We need buildings that can actually withstand that kind of stuff. So where does framing come in?
Well, framing is like the foundation of resilience, literally.
Yeah.
When you see those pictures of places that have been hit by hurricanes, the buildings that are damaged the most, they're usually the ones where the framing has been compromised. And traditional wood framing, while it's, cheap, it's not so good when it comes to things like rot, pests, and obviously fire.
Right, those are big problems, especially over time. So how do those newer framing systems compare? Like, in terms of resilience?
Well, we already talked about aluminum, and that's
Mm.
a good example, like the MHS system, because it doesn't corrode. It's a good option if you're building in an area that's prone to flooding,
Mm.
or if there's a lot of humidity, and you don't have to worry about termites or rot. Plus, it's surprisingly strong for how light it is.
Right, it's like building a bunker. But what about earthquakes? They seem like a whole different challenge. It's more about being flexible than just being strong, I guess.
You're absolutely right, and that's where post and beam really shines. It doesn't matter what material you use, because the weight is concentrated on those vertical posts and beams. The whole structure can actually move with the forces of an earthquake, instead of just being rigid and breaking.
Oh, wow. So it's like the difference between a tree that bends in the wind and a branch that snaps.
Exactly. It's designed to absorb and distribute those shocks, which is really important in earthquake zones. And then if you choose materials like engineered timber or steel, you can make it even more resilient.
So it's about combining smart design with the right materials, which makes me think about fire resistance. Are there any new developments in that area, especially with all the wildfires we've been having?
There are definitely some exciting things happening. One thing that people are doing is treating regular lumber with fire-retardant chemicals, which can really help prevent it from catching fire, and it slows down how fast the flames spread.
So it's like taking the traditional wood framing and giving it a high-tech upgrade. But are there any materials that are just like naturally fireproof?
Oh yeah, for sure. Steel framing is becoming more popular in places with a high risk of wildfires because it's completely non-combustible. And there's also some really interesting stuff happening with concrete framing systems, which are also extremely fire resistant.
So there are options. It seems like each material has its own strengths when it comes to resilience. So it's about choosing the right one
Yeah.
based on the specific risks in that area.
Yeah, exactly. It's like, using the right tool for the job.
Hmm.
But it's not just about the framing itself. It's also about how it all fits together with the overall design of the building. Things like what kind of roof you use, where the windows are placed, even the landscaping can play a role in mitigating risks.
Right. It's all connected. It's like a holistic approach to resilience. You have to think about everything. But I have to admit, when you're talking about all this stuff, resilience, high-tech materials, it sounds expensive.
I hear you. It's true that building for resilience usually means spending more upfront. But I like to think of it as an insurance policy. If your house can survive a hurricane or a wildfire, you could be saving yourself a ton of money, maybe even hundreds of thousands of dollars in repairs or having to rebuild.
That's true. You're paying it for peace of mind. And you might save money in the long run. But it's not just about the money, right? There's also the human side of things. Communities that are built to be resilient, they're probably going to bounce back faster and stronger after a disaster.
Absolutely. Building for resilience isn't just about protecting buildings. It's about protecting people. And it's about community. Imagine a neighborhood where all the houses are designed to withstand a hurricane and where everyone knows each other and is ready to help each other out. That's what real resilience looks like.
Yeah, it's amazing. It's about more than just the buildings themselves. It's about the people and how they come together. Wow, we've covered a lot of ground today. We started with the basics of post and beam framing, then we talked about some crazy innovations that are coming up, and now we're talking about building for a future that's, well, a little bit unpredictable.
Yeah, it's been quite a journey. And I think it shows how complex sustainable building really is. It's not just about using eco-friendly materials. It's about designing buildings that are durable, efficient, adaptable, and most importantly, resilient, no matter what the future throws at us.
And it's about giving people the knowledge they need to make informed choices about their homes and communities, choices that put people and the environment first.
I couldn't have said it better myself. We've given you a lot to think about today, and I really encourage you to keep exploring these topics. Do some research about the options in your area. Find architects and builders who share your vision. And don't be afraid to ask questions.
Yeah, remember, every step we take towards a more sustainable and resilient future, even if it seems small, it's all part of a bigger effort. It's about creating a world where our homes and communities are more than just places to live. They're sources of strength and inspiration for generations to come. Thanks for joining us on this deep dive.